Hi again, Captain Peter Cutsey with another of my online self-briefings. Today we are going to complete part one of a series in adverse weather from the supplementary procedures. Everything I'm briefing you on comes directly from the FCOM, just a little easier to study with in a PowerPoint presentation and a video and the simulator as we go into parts 2, 3, and 4. The first part of the adverse weather portion we're going to speak of is cold weather operation. Here's an overview, and considerations associated with cold weather operations are primarily concerned with low temperatures and with ice, snow, slush, standing water on the airplane, ramps, taxiways, and runways. Icing conditions exist when the outside air temperature on the ground or the TAT in flight is 10 degrees Celsius or below, and any of the following exist: visible moisture, such as clouds, fog, with visibility of 1 statute mile at 1,600 meters or less, rain, snow, sleet, ice crystals, and so on is present, or ice, snow, slush, or standing water is present on the ramps, taxiways, or runways. There's a caution here in the FCOM: do not use engine anti-ice or wing anti-ice when the outside air temperature on the ground or the TAT in flight is above 10 degrees Celsius. One other note that has been remiss and not mentioned in the last many years regarding icing conditions: if the temperature dew point spread is less than 3 degrees, 3 degrees or less, that's an indication of moisture content. The exterior inspection, although removal of surface snow, ice, and frost is normally a maintenance function, during pre-flight procedures, the captain or first officer should carefully inspect areas where surface snow, ice, or frost could change or affect normal system operations. Do the normal exterior inspection with the following additional steps. Surfaces, check. Take off with light coatings of frost up to 1/8 of an inch, that is 3 millimeters in thickness, on the lower wing surfaces due to cold fuel is allowable. However, all leading edge devices, all control surfaces, tab surfaces, upper wing surfaces, winglet surfaces, and control surface balance cavities must be free of snow, ice, and frost. Control surface balance cavities, check. Check drainage after snow removal. Puddled water may freeze in flight. Pitot probes and static ports, check. Verify that all pitot probes and static ports are free of snow and ice. Water rundown after snow removal may freeze immediately forward of static ports and cause an ice buildup, which disturbs the airflow over the static ports, resulting in erroneous static readings even when static ports are clear. Air conditioning inlets and exits, check. Verify that the air inlets and exits, including the outflow valve, are free of snow and ice. If the APU is operating, verify that the outflow valve is fully open. Engine inlets, check. Verify that the inlet cowling is free of snow and ice. Verify that the fan is free to rotate. Snow or ice that accumulates on the fan spinner or fan blades during extended shutdown periods must be removed by maintenance or other means before engine start. Snow or ice that accumulates on the fan spinner or fan blades as a result of operating icing conditions such as during approach or taxi in, is allowed if the fan is free to rotate and the snow or ice is removed during the ice shedding procedure during taxi out and before setting takeoff thrust. This ice shedding procedure is a QRH procedure. And when you follow it, ensure that there's nobody closely behind you. Better to do it perhaps at the holding point when you're 90 degrees to the runway and no one is behind you because of the increased thrust. Fuel tank vents check. Verify all traces of ice and frost are removed. Landing gear doors check. Landing gear doors should be free of snow and ice. APU air inlets check. The APU inlet door and cooling air inlet must be free of snow and ice before starting the APU. Takeoff on wet or contaminated runways. The following information applies to takeoffs on wet or contaminated runways. Let's talk about wet runways first. Reduced thrust, fixed D rate, assumed temperature method, or both is allowed. Providing suitable takeoff performance accountability is made for the increased stopping distance on a wet surface. Most companies now have an OPT, operational performance tool, which will give you all this information. So follow your company SOPs. For runways contaminated by slush, snow, standing water, or ice, reduced thrust fixed rate is allowed, and I would recommend it. Provided takeoff performance accounts for the runway surface condition. Reduced thrust using assumed temperature method in combination with a fixed rate is not allowed. Follow your company SOPs for any other situation that would prevent you from using assumed temperature method, or even prevent you from using the D-rate method, depending on the serviceability of your aircraft. V1 may be reduced to minimum V1 to provide increased stopping margin, provided the field length required for a continued takeoff from the minimum V1 and obstacle clearance meet the regulatory requirements. The determination of such V1 may require a real-time performance calculation tool, OPT, as we've just mentioned previously, or other performance information supplied by your flight dispatch. Takeoffs are not recommended when slush, wet snow, or standing water depth is more than a half inch, 13 millimeters, or dry snow depth is more than 4 inches, 102 millimeters. You follow your company SOPs. Let's get into some of the changes. The next is the pre-flight procedure. Do the following steps after completing the normal pre-flight procedure. So these are additional steps. Probe heat switch is on. So that's sooner than you would do on a normal check. That's to give the windows a chance to warm up. Today, in our example, we're going to be at Belgrade, and the temperature is -35, and the airplane's been sitting all night outside. So you want to preheat those windows as soon as possible. That's why this procedure is in the supplementary procedures. Engine start procedure. Do the normal engine start procedure with the following modifications. If the engine has been cold soaked for 1 hour or more hours at the ambient temperatures below -40, do not start or motor the engine. Maintenance personnel should do the appropriate procedures for adverse weather heating of the hydromechanical unit. If the engine has been cold soaked for 3 hours or more, hours at ambient temperatures below -40, do not start or motor the engine. Maintenance personnel will do the appropriate procedures for adverse weather starter servicing. If ambient temperatures are below -35, idle the engine for 2 minutes before changing the thrust lever position. So we're close to that today with the temperature at -35. So we must take heed. Several minutes may be needed for oil pressure to reach the normal operating pressure. During this period, the oil pressure may go above normal range and the oil filter bypass light may illuminate. Operate the engine at idle thrust until the oil pressure returns to the normal range. If the oil pressure remains above the normal range after the oil temperature has stabilized within limits, shut down the engine. Display units may require additional warm-up time before display engine indications accurately show changing values. Display units may appear less bright, as this text is, than normal. Engine anti-ice operation on the ground. Engine anti-ice must be selected on immediately after both engines are started and remain on during all ground operations when icing conditions exist or anticipated. If you've noticed, I put in brackets after each engine. After all these years, I'm not quite sure what Boeing mean after both engines are started. I would highly recommend that after you start, let's say engine number 2 first, or whatever engine you're starting, that you put the engine anti-ice on and start protecting it the moment the engine is at idle. Because if you start the other engine and you have a problem with the other engine, you may be several minutes before coming back to this comment after both engines are started, and you may have a major problem of losing an engine on takeoff because you didn't protect it after you had started it. So I would recommend that Boeing change both to after each engine is started. Follow your company SOPs. What I'm talking to you about is called airmanship. Warning, do not rely on airframe visual cues before activating engine anti-ice. Use the temperature and visible moisture criteria because any late activation of engine anti-ice may allow excessive ingestion of ice and result in an engine damage or failure. That's why I mentioned the temperature dew point spread of less than 3 degrees with conditions under temperature of 10 degrees Celsius or less. Very important because you can't see that. Caution, do not use engine anti-ice when the outside air temperature is above 10 degrees. When engine anti-ice is needed, engine start switches continuous. That's the first officer's duty. Engine anti-ice switches on. First officer. Verify the call, valve, open lights illuminate bright, then dim. Verify that the call anti-ice lights are extinguished. Also verify that the TAI lights on the upper display are visible in green. Little pickies, bright, dim, bright, dim. Note, if the call valve open lights remain illuminated bright and with engine at idle, position the APU bleed air switch to off and increase thrust slightly up to a maximum of 30% N1 in order to get the proper flow through the engines. All right. Okay. Let's go to wing anti-ice operation. Before we do that, also, don't forget to check the TAI visible after selecting engine anti-ice on. Here they are here, and they should be green. If they're amber, you've got a problem with the valve. It's not fully open. And then that would be a checklist item immediately. Okay, wing anti-ice operation on the ground. Use wing anti-ice during all ground operations between engine start and takeoff when icing conditions exist or anticipated, unless the airplane is or will be protected by the application of type 2, which is a yellowish peach color, or type 4, which is a green color fluid, in compliance with an approved ground de-icing program. So if you're going to use wing anti-ice, you have to make sure that you haven't sprayed with either type 2 or type 3. You don't use wing anti-ice if you use type 2 or type 3 because it's going to cause a problem on takeoff. That's why if you've watched my video series playlists on YouTube of a no engine bleed takeoff and landing, why we talk about wing anti-ice, etc. So you get into that, you'll have a better understanding of what we're talking about here. All right, warning, do not use wing anti-ice for an alternative, as an alternative for ground de-icing or anti-icing. Of course not. Close inspection is still needed to ensure that no frost, snow, or ice is adhering to the wing, leading edge devices, stabilizer, control surfaces, or other critical airplane components at takeoff. Listen, I used to do the walk around being from North Bay, Ontario, Canada, and being in that part of the world, the temperatures quite often got to -40. I can remember on many occasions flying the DC-9 to Timmins, Ontario, and the airplane sat overnight. When it came time to go the next day, even though the weather was clear, there was a good possibility that there would be frost or ice adhering to the wings that you couldn't see. So I used to get up with maintenance on the baggage loader and touch the wing. And I was sure then that we had a requirement to de-ice. So make sure that the airframe is clear, is what I'm saying. Caution, do not use wing anti-ice when the outside air temperature is above 0 degree or above 10 degrees. Do not use wing anti-ice when outside air temperature is above 10 degrees. All right. Wing anti-ice operation on the ground. When wing anti-ice is needed, wing anti-ice switch on. That's the first officer's duty. Verify that the left and right valve open lights illuminate bright and then dim. Before selection, on selection, and checks out. Bright and then dim. Note the wing anti-ice valve open lights may cycle bright dim due to the control valve cycling closed open in response to thrust setting and duct temperature logic. When wing anti-ice is no longer needed, wing anti-ice switch off, and that is the first officer's duty. Bright, then extinguished. Well, there you have it. That's the end of part 1. There will be more parts to this very important topic in any aircraft operation. Thanks for watching. See you in part 2.